In problem number 3 here, we are again looking to isolate the radical. So I'm going to go ahead and add x on both sides. These cancel out on the right, leaving me with x minus 10 on the left and the square root of 6x minus 5 on the right. So now that I have my square root isolated, we're going to go ahead and undo it by squaring both sides. We see that the square and the square root undo each other, so I'm just left with 6x minus 5 on the right. On the left, again, remember, this is really x minus 10 times another x minus 10. All right, so once I FOIL everything, we're going to end up with x squared minus 20x plus 100. I can then set this equal to 0. We have a quadratic, so I'm going to try to set equal to 0 and then factor. I'm going to move the 6x over to the left by subtracting, 6x. And then I'm going to try to add the 5 to the left side. So we see that the 5's cancel and the 6's cancel, leaving me with nothing on the right side. And then on the left, we have x squared minus 26x plus 105. So we're going to try to factor this. I'm looking for two numbers that multiply to be 105 and that add up to equal negative 26. All right, and hopefully you realize that those two numbers are negative 21 and negative 5. And negative 21 and again negative 5 will work for both of those scenarios. So that means this factors to be x minus 21 and x minus 5 equals 0. And so we get answers of 21 and positive 5. So again, you do have to go back and plug these in. So when I go ahead and I plug in positive 21, I do get that to work out. Okay, that does give me a true statement when I plug in positive 21. When I plug in 5, however, we get a false statement. This is not true, okay? We can just double check on that really quick. If I plug in a 5 here for that x value, we get 30 minus 5 is 25, and the square root of 25 is 5. If I take a negative 5 plus 5, that does not equal the negative 10. So that does not work out to be true. However, if I do plug in a positive 21, that does work out to be a true statement. All right, so trust me when I say plug in that 21, you will get this right side to equal negative 10 there. All right, last example here, we have x equals the cube root of 4x cubed minus 24. So for a problem like this, we have a cube root. Now it's already isolated, which is great. So to undo this cube root, I just need to cube both sides. So I'm going to cube the right and I'm going to cube the left. We know that the cube and the cube root cancel out. So x cubed equals 4x cubed minus 24. And then I'm going to try to get the x's all by themselves. So I'm going to subtract that 4x cubed on both sides. And then we get negative 3x cubed equals negative 24. Let's go ahead and divide both sides by negative 3. And we see that x cubed equals 8. And if x cubed is 8, then when I take the cube root of both sides, we know for sure that x is going to be 2. All right, so x is 2. Again, it is important to double check your answer. So when I plug in a 2, you do find out that this is in fact a true statement when you plug in the 2. All right, so remember, isolate your radical, use inverse operations. And then once you solve and get your answer, really be sure to plug it in and double check to make sure it actually is a solution.